So in this video, we're going to be talking about the evolution of a chemical equation. And we're going to start by talking about a reaction that I think I've mentioned before. If you take a solid piece of sodium and add it to liquid water, a reaction occurs producing hydrogen gas, sodium hydroxide solution, and heat. And that's what's going on here. There's a little bit of sodium in this picture. It's being added to water. And this is kind of the hydrogen gas coming off, and it produces heat. And this is actually a very violent reaction. And so I thought I'd show a video on the next slide of it because this picture kind of doesn't do it justice. So let's see if this video will play. Give me a second here. There you go. Let me skip ahead. So they have this giant, I think it's a pound of solid sodium that they're going to throw in this pond to see the reaction. So let me turn this up so you could hear it. Okay, so here we go. Just some people in their backyard, I guess. Here you go. So they're going to throw it in the pond. There it goes. And here's the reaction. Okay, so the reaction is much more violent and cool looking when you actually see a video. And there's people like blowing up toilets with it and all sorts of stuff. If you just look up sodium in water or potassium in water, things like that. It's pretty cool to watch. Okay, so evidence of a chemical reaction, to say the least. I'll just try to get rid of these guys now. There we go. Okay, so what's going on here? Chemists can write this out, this reaction. So chemists have developed a standardized shorthand method for describing chemical reactions like the one we just saw. So before we do that though, so the reaction is shown here. So you have sodium plus water gives me hydrogen gas and sodium hydroxide. That's what we mentioned before is the reaction of sodium with water. And so there's these new things here that I can't remember if we've seen before, but these are state symbols. These tell us the state of each one of these molecules or elements. So for example, sodium, this S means solid. So you take a solid piece of sodium, you put it in liquid water, that's what the L there is for, and it'll give you hydrogen gas, okay? And sodium hydroxide, aqueous is what this means, which means sodium hydroxide dissolved in water, okay? So chemists use these state symbols to represent what's going to happen in the chemical reaction. And we're not going to see this so much in this chapter, but we are going to see it later on in the semester and use this as we go on. All right. So remember in the previous video, I said that we need to balance chemical equations because the number of atoms and the type of atoms on one side of the equation needs to match the type and number of atoms on the other side of the equation. So if we just look at the equation here on the top, whoops, let me get my pen back. Sodium plus water gives me hydrogen and sodium hydroxide. This is an unbalanced equation because the number of atoms of each element is not the same before and after the chemical change. So for example, we have 2 hydrogen atoms here on the left, and we have, excuse me, 3 hydrogen atoms on the right side of the equation. So this is a problem. So an equation is balanced then by placing a coefficient in front of one or more of the formulas, indicating that it's used more than once. So here's the balanced chemical equation. So 2 sodiums plus 2 water molecules gives me hydrogen gas molecule and 2 sodium hydroxide formula units. Okay, so again, this is the way that we represent that the number of atoms and the types of atoms are the same on both sides of the equation. And once balanced, this is going to be really helpful for us later. An equation is both a qualitative and a quantitative description of the reaction. And we're going to talk about what that means in a later video when we start using these chemical equations to solve some problems, okay? But just know for now, we need to balance these chemical equations. Okay, so here's the do's and don'ts of balancing chemical equations. So you do balance chemical equations entirely by using coefficients placed before the different chemical formulas. That's all we're gonna do, okay? We don't change or correct chemical formulas in order to make an element balance. So, we don't start adding things, adding different molecules, adding different compounds in there to make it balance. That's not gonna work. That's kind of the next one. You don't add some real or imaginary chemical species to either side of the equation just to make the elements balance. We don't want to do that, okay? We're just going to place coefficients in front of the chemical formulas, okay? That's all we're going to do. Place before. That's it. So here we go. This is our first example, and then we're going to have a video coming up where we're going to dive deeper into balancing chemical equations. And then throughout the rest of this chapter in next week's videos, when they come out for this chapter, we're going to do plenty of examples of balancing chemical equations. So let's ask ourselves, are the following equations balanced? And why don't you just pause the video and try to answer that question for yourself. Are the following equations balanced? Well, let's see. So let's just write what we have. So we have hydrogen, carbon, oxygen on either side of the equation. And let's just count how many we have, right? So on this side of the equation, I have 2 carbons, okay? I have 4 hydrogens, and I have 1, 2, 3, 4, 5, 6, 7 oxygens, okay? So there's 6 oxygens here, and there's 1 oxygen there. So I have 7 oxygens on that side of the equation. On the other side of the equation here, I have 2 carbon atoms. That's good. I have 4 hydrogen atoms, okay? Right, 2 times 2. And I have, okay, 2 times 2, I have 4 oxygen atoms here, and 2 times 1. If you remember on our video when we were talking about chemical formulas, there's that imaginary 1 there, or there's a 1 there that's implied, I should say. It's not imaginary, okay? So we have 2 oxygens there, so that's 6 oxygens. So no, this equation is not balanced, okay? Because we do not have the correct amount of oxygens on either side, all right? We have 7 on the reactant side and 6 on the product side. So the answer here is no. Okay, what about this one? Well, same idea here, hydrogen and oxygen. This is much easier, hydrogen and oxygen, okay? I have 2 hydrogen here, 2 oxygen here, 2 hydrogen here, 1 oxygen here. So the equation is again not balanced, okay? So this is just an example of us looking at an equation and figuring out if it's balanced or not. In the next video, we're going to talk about, all right, how do we balance those equations then? So that's what we're going to do next.